Thanks so much, and so exciting to be here on the first OpenSearch Con in Europe. So big round of applause also for the organizers. That's amazing. Amazing to see this happening and the community here, the OpenSearch community in Europe. And today on this talk, I'm going to share with you how we gained observability into our CI/CD pipelines. We at Logs.io, at my company, and how you can too. I'll use Jenkins as the reference, but the focus is not about Jenkins as a tool, but rather on the principles and patterns so that you can implement them also with other tools of your choice. And let's start with a day in a life of a developer on duty or an on-call engineer. And that's what it used to be like back in the day with us at Logs.io. So the developer on duty, the on-call, first thing in the morning, they start the day, they're going on over the Jenkins pipelines. You probably, who works with Jenkins in this, with a show of hands? Okay, not many, but anyway, that's a screen that Jenkins users know very well, and go over it one by one and checking the pipelines for the last few hours and see if there's any reds. That's the red, and especially if there's a red master on the master branch. And if you do find failures, well, if you don't find the failures, you can carry on with your coffee, like you see here in the picture. If not, you jump in, and then you need to go over one by one and understand what happened, where it happened, why it happened, and so on. And when I say need to go one by one, it's very important because we have different pipelines. You have the back end, we have the app, the front end, we have smoke tests. So you need to really go into each one to try and start mapping across runs, across branches. And also there's no easy way to compare that with historical behavior to know how it used to be in the past. So that's, and if we look at some examples of questions that we found pretty elementary, I'm sure that you'll agree, that we found rather challenging to answer. Things such as, did all runs fail on the same app? On the same step, sorry. Did all runs fail for the same reasons, and how many? Did the failure occur on a specific branch, or maybe on a specific machine? Which failed the most? If we see suddenly a spike in latency, is that normal? Is that really a spike? What is the normal? What's the benchmark? And so on. So these sorts of questions, it took us too much time to answer, too long to answer, and we realized we need to improve. And remember these questions, we'll go back to them later. So a word about myself. My name is Dotan Horovits. I'm the principal developer advocate at Logs.io. Logs.io provides a cloud-native observability platform that's based on popular open source tools, obviously OpenSearch that we all know here, but also OpenTelemetry that you've heard already about this morning, and I'll mention a bit today, Jaeger, Prometheus, and others. So that's Logs.io in a nutshell, and just giving you it in a managed, fully managed, and ready for scale in an easy way. So that's Logs.io, and by the way, this is from, someone asked me if it's my first visit to Berlin, so it's not my first time visit to Berlin, and I looked this up just before the talk. This is from 2 years ago, about the same time of year. Wishing everyone, as I will today, may the open source be with you. So May the 4th, for those who don't know, May the 4th, that's the geek day for Star Wars fans. And being both a Star Wars fan and an open source fan, so may the open source be with you. I also am a CNCF ambassador. CNCF is the Cloud Native Computing Foundation, the foundation under which Kubernetes is, and Prometheus, and Jaeger, and OpenTelemetry, and many other projects you probably know and use. That's the open source foundation. I also have a podcast called Open Observability Talks. So if you're interested in open source, observability, DevOps, do check it out in English on your favorite podcast app or on YouTube. And you can find me everywhere, as you can see, at Horovits. So if you're tweeting or tooting or posting anything from this talk, do feel free to tag me. So let's go back to what we talked about. And before I go into how we improved our CI/CD, I want to first understand what we want to improve on. And this is something that I see keeping on occurring with people that jump into the optimization before they really understood and defined the KPI that they want to optimize on. And for that, I really like the framework of the DORA metrics. Who knows the DORA metrics with a show of hands? Not many, so maybe I'll say a word about that. DORA metrics for DevOps. It started as a research to understand what makes high-performing teams. And back in 2018, they published a book, the Accelerate book, it's nicknamed, in which they identified essentially 4 key metrics that indicate the performance of your software development lifecycle, if you wish. And going over them, by the way, if you want more information, the QR code or the short link at the bottom gives a very good introductory article. So you're welcome to scan them. But just going very briefly, 4 metrics. First is deployment frequency, which is how often an organization successfully releases to production. Then there's the lead time for change, or sometimes it's called cycle time. That is the amount of time it takes a commit to get all the way into production. Then there's the change failure rate, the percentage of deployments causing failure in production. And lastly, there's the mean time to recovery, or sometimes called time to restore service, which is how long it takes an organization to recover from a failure in production. Okay, so these are the 4 DORA metrics. And again, remember, you need to understand first what you want to optimize on in terms of the KPIs. In our case, it was the lead time for changes, the amount of time it takes a commit to get into production, which was, in our case, too high and was holding us back. And as I mentioned, at Logs.io, we are experts in observability. That's what we do for a living. So we realized very quickly that what we're lacking is observability. Observability into our CI/CD pipeline. As I mentioned before, we use Jenkins as our tool. And Jenkins did and does provide some sort of observability out of the box. You can go into a specific run and see for each step how much time each step took. So there is some sort of observability that you can get out of that. And we also wire Jenkins with our alerts to Slack and things like that. But that wasn't good enough for us. And the reason is that we wanted to find a way to monitor aggregated and filtered information across all the pipelines, across all the runs, across all the branches, across all machines, in order to see a full picture on a scaled time range with our own filters and demands. Okay, so this is a dashboard that I'm going to mention, but the dashboard is not the point. The point is how we get the observability. And essentially, what we needed, if I summarize the requirements of this project, we had these requirements. So first, we wanted dashboards and aggregated views to see across pipelines, runs, and branches. Then the ability to see historical data, to understand trends, and to identify patterns, essentially. Then reports and alerts to automate as much as possible. And lastly, we wanted also to be able to get observability into the test performance, to be able to identify flaky tests, test performance, and to understand their impact on the pipeline. And now that we understand what we want to achieve and what we are optimizing on, let's talk about how to achieve that. And essentially, it takes 4 steps. As you can see here on the screen: collect, store, visualize, and report. And in terms of the tech stack, we have a lot of expertise in OpenSearch. As I mentioned, it's an integral part of our system. Before that, we were power users of the Elk stack. So this was, for us, a natural place to start our journey. And this was definitely the first step. So let's see these 4 steps that we went through with OpenSearch. So let's talk about the first step, the collect phase. Okay? For that, we instrumented the pipeline, the Jenkins pipeline, to collect all the relevant information that we can get and put it in environment variables, essentially. And what kinds of information are we talking about? You can see some examples here. The branch, the commit SHA, the machine IP, run type, whether it's scheduled, triggered by merge to master or by push to branch or whatnot, failed step, step duration, build number, and so on. So really, anything that is meaningful for you or that you think might be meaningful, that's the time to collect it. That's the collect phase. Next is the store phase. And for that, we created a summary step within the, I highlighted this on the screen, an additional step at the end where we ran a command to collect all the information from the environment variables that we talked about and created the JSON with the pipeline data and persisted it, stored it in OpenSearch. And we have our own managed, of course, so it's a no-brainer for us. And it's important to say, Jenkins does have some built-in persistence. So we tried that, and the thing is that we found some downsides to what Jenkins provides out of the box. I know that there are some Jenkins users here, so it's important to note, and also for those who are using different tools to understand the trade-offs. So for us, the problems were that first, by default, Jenkins keeps all the builds and stores them on the Jenkins machine, which obviously burdens these machines that are critical for our build process. And you need to then start to limit how many builds to keep for how many days and all of that considerations. And we also wanted to persist the historical data on our control. Okay, we wanted to persist to control the duration, the retention, and as I mentioned, to do it off the servers, the Jenkins servers, so as not to load the critical path. And as I mentioned, also powerful access to historical data so that we can analyze the same way that we analyze our production environments, essentially. So that's about the store data, and then let's talk about the visualize. Now that we have all the pipeline run data within OpenSearch, it's very easy to build dashboards and visualizations in OpenSearch dashboards. And now the question is, which visualizations? Okay? And here I want to take you back to the questions we were facing earlier on. Remember these? Did all runs fail on the same step? Did all runs fail for the same reason? And how many failed for that reason? And whether the failure occurred on a specific branch or on a specific machine? All of these questions are important because once you define the questions, this will help you define the dashboarding and the visualization that you need to set up. So, and I'm emphasizing the principles because you don't need to copy and paste exactly what I did. The importance is to understand the process, to understand how you elicit, you clarify what the questions, what kinds of observability you want, and then derive what kinds of visualizations you want to build around them. So I'll give a few examples. Again, it's just examples to show you how you map a need into a visualization. And let's start with the top line status. Okay? Check how stable our pipeline is. For that, we created the visualization of success and failure rates. And you can see both two types of visualization, in general and a specific time window. And imagine you're the on-call, you're the engineer, wake up in the morning, remember that scenario? You open and you see that. That's very easy to see if you can finish your coffee or if something problematic happens. So that's like the top-line view. Next, finding problematic step. For that, we created this visualization of failures segmented by pipeline steps. So again, very easy to see, suddenly a spiking step that had many more failures. Let's now talk about detecting problematic build machines. So again, visualizing failures segmented by machine, and that proved to be very, very useful, right? Saves us from wasting time looking for problems in the delivered build, the released code. Instead, when it's a problematic machine, you don't even bother asking why it's problematic. You just kill the machine. You let the autoscaler spin up a new one, and many times it just solves the problem. So really useful to understand whether it's environmental or code-based issue. Another example, understanding the duration per step. Visualization. Before we collected the CI/CD pipeline data, as I mentioned, Jenkins did provide us with the steps, but you needed to go into the specific run. And then you saw the steps of that specific run. Here, you have what we lacked then, is the aggregated view. So here, we can see everything across runs, across branches, filtered based on our interest. So just to summarize before we go on, these are some examples of visualizations, but you'll create your own based on your questions and your needs of observability. So that's the visualize, and after visualize comes report. As I mentioned before, the developer on duty needed to go manually into Jenkins and check the pipelines. Now, the developer on duty, the on-call, just gets a daily start of day message on Slack that you can see, the report on Slack. As you can see here, he gets the link, he or she gets a link directly to the dashboard so you can do the drill down into the issue if there is one, but also a snapshot within Slack itself. So as I mentioned, if you see all green, you can carry on. You don't need even to go jump into the dashboard. So very, very useful. And we can also define alerts, of course, on the data, the same data that is already on OpenSearch. We can define triggered alerts. It could be also complex conditions. So you can say things such as if the sum of failures goes above X or the duration goes above Y, trigger an alert. So it's really flexible. And as I mentioned, this is a scheduled one, but you can have alert-triggered alerts very similar to that. And you can define Lucene queries, just like you probably all know as OpenSearch users. Whatever you can express in Lucene, you can create an alert on. And this is done by an alerting mechanism we built on top of the OpenSearch and pretty cool stuff to see. And also, it's very important. We work with Slack with our engineering and DevOps teams, but you can also use other endpoints depending on what you use. So if you want things such as PagerDuty, OpsGenie, MS Teams, whatnot, I hope we can say MS Teams. So just kidding. So anyway, depending on your choice, we work with Slack on our engineering, so that was our choice. So that was observability for our Jenkins. But Jenkins is not everything, okay? CI/CD is more than Jenkins. So what else did we want? I don't know if you remember from the mission, statement that we had before, the goals of the project. We also wanted to analyze flaky tests and test performance. So for that, we followed a very similar process. We collected the relevant information from our test run and stored it in OpenSearch, and then created the OpenSearch dashboards visualization. And you can see lots of useful things for us. Again, you can do your own things, but test duration, fail tests, flaky tests, failure count and failure rate, moving averages, and failed test by branch over time, and so on and so forth. So really, depending on what you need, that was very, very powerful for us. And following the visualization, remember the same flow, also reporting. We set reports and alerts into a dedicated build alert Slack, as you can see here, that the team got as soon as we started seeing daily and alerting if we needed. Okay? So another point that is very important is the flexibility and the openness. Okay? Once you have the data in OpenSearch, different teams within the same organization can actually create different visualizations depending on their preferences and their styles. And I took the other extreme, a team that preferred only numbers and no charts for very similar needs. So they created different visualizations, but essentially serving the same purpose. So that's a flexibility that you can store everything, and then the visualize step can be done differently by different teams depending on their needs, their observability styles, preferences, and so on. So really powerful. And by the way, I talk quite a bit about platform engineering in other forums. Platform engineering, by the way, is very important in this process if you do have it at home, because they can create this facilitation, then give the freedom to the different teams to create the visualization, the reporting they need, and on top of that, facilitation. So just to summarize, we saw that we instrumented Jenkins pipelines to collect the relevant data and put it in environment variables. That's the collect phase. Then at the end of the pipeline, we created the JSON. We persisted it. We stored it, indexed it in OpenSearch. And then we created visualizations on top of the data. And lastly, created reports and alerts on the data. So 4 steps: collect, store, visualize, and report. Okay? If there's one thing to take out of this talk, remember these steps. So what's next? Okay? what if we want to investigate the performance of specific pipeline runs? And before I showed the aggregated per step that we created on OpenSearch dashboards, but what do we really want to drill down into the pipeline steps and see the optimization and what takes, what runs in sequence, parallel, where the bottlenecks are, and so on. And that's what distributed tracing is for. So our next journey, and a step in the journey, was actually to explore distributed tracing for CI/CD. And the nice thing is that Jenkins knows how to emit this data as spans, as trace data, and over OpenTelemetry, I'll mention that. So we decided to visualize the jobs and the pipeline executions as distributed traces. So I'll skip the basics on distributed tracing for lack of time, but just to show you, it's the same principle. I'm going over that pretty quickly, right? We're probably about to, how are we with the time? OK, so just to show you the same principle. Collect, in this case, I did it with OpenTelemetry. So OpenTelemetry collectors, Jenkins has the built-in Jenkins OpenTelemetry plugin. Configure Jenkins, send the collector, and then configure the collector, sending, and voila, you have a pipeline visualized as a trace. Very nicely seeing each step of the process, and getting the full visualization with the Jaeger UI. And as before, it doesn't have to be only Jenkins. You can go and explore additional things like Maven builds and Ansible and so on. You can break down even finer granularity if you have these. So you can take it even deeper. So that's with traces, and you can do similarly with metrics on your system, following the same steps. In this case, I gave another example. You can do that with Telegraph, but just as an example, storing it into Prometheus. And the most important thing, then, once the data is there, you can visualize the branch, machine ID, build number, filtering. You can do CPU, memory, disk usage, load, trends over time. You can do things such as on the container level. So that was the operating system. You can do on the container level, like the container CPU and memory and I/O and so on. And also you can do that on the JVM. For those who don't know, Jenkins runs on Java-based, so it's JVM-based. And then you have metrics like thread count, heap memory usage, garbage collection duration, things that you would probably explore in performance in these respects. And of course, the native Jenkins, like Jenkins queues, Jenkins jobs, they have their own metrics like queue size, status breakdown, count, executed over time, and so on and so forth. So all of that you can visualize, again, just understanding if it's machine-related or code-related. And when it is environmental, this is the drill down. So just to summarize, treat your CI/CD just like you treat your production environment. Okay? Just like you use OpenSearch and maybe Prometheus and maybe OpenTelemetry and others for your production environment, use the same for CI/CD. Even you reuse the same stack so you don't reinvent the wheel. And we embarked on these goals, dashboards and aggregated views. I showed you historical data and controlled persistence of the Jenkins servers, reports and alerts to automate as much as possible and test performance, flaky tests, and so on. 4 steps to take it. Again, collect, store, visualize, and report. That's what you need. And remember what we gained. So we gained significant improvement in our lead time for changes, the DORA metric we talked about before. We improved the developer on duty on-call experience. And it's based on the open source stack that we know and love, such as OpenSearch and OpenTelemetry. If you want to read more, you have a QR code here for a more long-form article that I wrote on the topic of CI/CD observability and how you can implement it in your systems. And there is a work in the CNCF, in the Cloud Native Computing Foundation, to standardize some of this stuff. So if you're interested in this topic, do reach out to me after this talk. Happy to talk about that. So this is the article. And may the open source be with you. Thank you very much.
Hello. So we have time for some questions. May you raise your hand if you have questions? Ask something. It's your time.
I'll give you a sticker. May the open source be with you if you ask an intelligent question.
It looks very good.
Whoa, even that didn't work.
Yes, we have one winner here.
Thank you. So thanks for the presentation and for the sticker. I wanted to ask you, so you showed that you use OpenSearch for logs, then Grafana and Prometheus for metrics, and Jaeger for distributed tracing.
Yeah.
I wanted to ask you if you have investigated also into using only open source for all of the telemetry signals.
Only open source or only OpenSearch?
Sorry.
So it's a good question. I didn't have time to explore, but essentially when we did this journey, now let's take a step back. I don't know who is versed with OpenSearch, but essentially OpenSearch in the 1.x had the first phase of experimenting with tracing. That was part of the observability plugin. And now at 2.x, there is its own experimental feature. But as I said, even now it's experimental in the 2.0. And when we started this, it was not even there. So we went with what we knew. And we already used Jaeger in our production. As I mentioned, the tip is not to reinvent the wheel. So we just took this stack that we used for monitoring our production environment, which is, in this case, was Jaeger. We just adapted it for the CI/CD pipeline. However, I think it's very important to say, and maybe the product team will maybe note on where it stands today. Once it's mature and not experimental, once it's GA'd, it's definitely worthwhile exploring if we can converge. So even in the shipping, I mentioned that like I showed the option with Telegraph and the option with OpenTelemetry. It's not recommended. The recommendation, if you can consolidate, it's simpler. It's simpler in managing the stack and the complexity around running it. So if you can consolidate, it's good. Just we're not there yet, I think, in some of the pieces with OpenSearch, and definitely not at the time that we did this journey.
Okay. I do have a question.
Yeah.
Nobody was expecting. So I'll ask a question. So what would you advise to, in the case that you are connecting this monitoring of pipelines to your Slack channels or your communication channels to not spam your team? What kind of metrics would be more relevant when we are observing pipelines in this way?
Well, that's a big question. I think first, it should be a dedicated channel. So whoever is not relevant for this channel just either is not there or is silenced unless you are on call. So it limits very much the blast radius of notification. So in our case, the approach was that you have the dedicated alerts, for example, the flaky test alerts, and you have the team leads and the people who need to know it, and if there is an on-call that needed to do that. That's the way that we segment in our Slack as a best practice. And about what you alert, that, again, is derived with what is the critical for you. So you need to define which metrics are the ones that are deal breaker for you, and which threshold, and only on these to generate the alert. So the tuning of alerts is part art, part science, but in general, the one that starts becoming painful, and oftentimes it comes from impact. So start with the impact, the ones that actually can now trickle down to the ops team. Like your customers in this case are the ops team, and try and put the bars before that gets there.
Okay, thank you so much. Do I have more questions from the audience? Okay, otherwise I would ask more questions.
Hi, thanks for the presentation. Do you somehow correlate the metrics, logs, traces, also across the two different tools, so using Prometheus for metrics and logs, traces, OpenSearch? Do you somehow correlate them?
So in general, we have quite powerful capabilities around the correlation part. That's a whole different topic that I didn't get into, but essentially what you do usually is that you see the metric and you can click, and then it opens up the relevant visualization in OpenSearch dashboards or on the trace view if it's something that is performance related. So, for example, you can start and see a top-line metric or that of a latency, and then you want to open up the trace and see where it comes down to. So we use that quite a bit. We use that, again, it's the same practices that we do on the operations. We do that now with the CI/CD, and we do that a lot. That you do this sort of a drill down phase from, okay, I see the symptom, now I want to take the next step. So I highly recommend it. A classic example in this case of the CI/CD is when I talked about when you have a problem and you want to understand if it's code-based or environmental. So you can do the first level code-based or environmental from the OpenSearch dashboard that I showed before, but then you want to say, okay, environmental, I gave it the simple solution, let's kill the machine, spin it up again with the autoscaler, and it will maybe pass. But sometimes when you see it persisting, happening too many times, you want to understand, okay, what causes it? For example, memory leak, garbage collection, things like that. So the next step will be, for example, what I showed with the metrics, for example, JVM metrics. So this is a classic flow that goes the other way. I start from the OpenSearch dashboards, and then I switch over to the metrics. Definitely very, very useful in these sorts of investigation flows to shorten your... The top line, remember, is the time it takes from the moment you find on the door metrics, the time that you find the problem to the time that you find the resolution, the lead time that you need. And we want to shorten it as much as possible. These correlations are a force multiplier in reducing and shortening this time.
Great, great. So
from this side, come on, they're asking all the sides. At least to show them that you're at least
interested.
No,
yeah. So I do have another question. Does anyone? Okay, great.
Yeah, thank you. I think it was a timely talk. But I think you're solving a specific problem of a more generalized, larger problem. Like, for example, if you have a simulation farm, or you're having a system that's trying to render images from a movie and so on, the same sort of strategies would apply over there. Are you looking at generalizing some of this to a higher level as well?
So, first of all, yes, the principles that I talked about are essentially observability. It's applying observability just in the case of CI/CD. So, in a way, it's a use case, one use case for observability, and the principles apply across different cases of observability. So, the flow that I talked about is the same flow: collect, store, visualize, and report. And also, a lot of the instrumentation, the tool chain, and so on are applicable in other cases. The reason I chose this topic is that I see that while the understanding when it comes to production systems is much more mature, people sometimes, and also us, even being a powerhouse of observability, we still neglected certainly the stepchild that we don't think of in the same terms. So the reason I go around and I talk about this topic quite a lot is because as engineers, we don't put the same effort and investment in observability in our release pipeline. And also, as part of my capacity as a Cloud Native Computing Foundation ambassador, we also started, as I mentioned, standardizing on that. So that different tools will emit telemetry based on on a unified schema, unified semantic conventions, and by the way, do that on top of OpenTelemetry. And then you could ingest it with OpenTelemetry and send it to whichever backend you wish. But you won't need to tailor it to Jenkins, and then if you switch from Jenkins to Circle CI or something else, then suddenly you need to reinvent the wheel. So it will be standardized. So this is one of the places I try to work with the community to standardize on the semantic conventions for CI/CD events so that we can do observability better in a more unified manner.
Yeah, I think that sounds about right. Yeah, I was wondering about the observability part, the cobbler's children wearing torn shoes.
Yeah, definitely. And by the way, as a tool, all the tool chain that I showed, all the open sources, and also our product as Logs.io is generic observability. You can use that for CI/CD pipeline. You can use it to production systems. You do that, some people do that on product metrics for their SaaS products and healthcare and whatnot. So observability is observability is observability. That's the bottom line, and that's why the tool chain, the stack, and even the Logs.io managed services are applicable for all of these cases.
Great, great. So I really think the force was with you in this talk. So I would like to ask a big applause for our speaker.
Thank you. Thank you very much.